Hello viewers, welcome to Auntie IJ's chemistry class. In this channel, I'll be helping you out with problems in chemistry. Today, we'll be learning another wonderful topic. Today, in our chemistry class, we are going to look at the topic, how to write the electronic configuration of ions. You know, last week we talked about writing the electronic configuration of elements using the quantum numbers. We use the principal quantum numbers and the subsidiary quantum numbers to write electronic configuration. Today, we are going to deal with ions. I know that before now you must have been taught on what an ion is. An ion is a charged particle. And that particle could carry either positive or negative charge. Now, positively charged ions are formed when the atom of an element loses electron. The number or the quantity of the charge carried by an ion determines the number of electrons lost. In that case, if you have a substance like this, say this is the atom of an element represented by the letter X, and you have X plus electron. The above equation describes the X as an atom that lost one electron to become univalent positively charged ion. In that case, if you have, say, an atom X with atomic number 12, it tells us that if you have this as an ion, if this is an ion, it tells you that the atom X lost 2 electrons. And in that case, if we are writing the electronic configuration of X, we will represent 10 electrons. That is subtracting the 2 electrons from the original 12 electrons possessed by an atom of that element. And at this juncture, I must tell us that in a neutral atom, the number of electrons equals the number of protons. Therefore, if you know the atomic number of an element, it means that you also know the number of electrons in the element or in an atom of that element. So here we have that X will now contain, this S contains 10 electrons. X contains 10 electrons. So if we are to write the electronic configuration of X, going with the quantum number K, L, M, N, where we have KB1, 2, 3, 4, and we have S, SP, SPD, SPD, F, representing 10 electrons. If we are writing the if we are to write the electronic configuration of X, so what we have is 1s2, 2 electrons, 2s2, making it 4, 2p6, and that ends it for electronic configuration of X2 plus 12. Now, if we are talking about the negatively charged ions, a negatively charged ion is formed when an atom of an element gains an electron. When an atom of an element gains electron, it forms negatively charged ion. For example, we can have Y being an atom of an element, and if it gains electron, it forms Y minus. That minus is -1. T being an atom of an element, gaining 2 electrons, will have the ion of T being T2 minus. So, going by this, we can now say, if we are given something like this, chloride ion with 17 as atomic number, which also represents the number of electrons, it tells us that this chloride ion contains 18 electrons. Why? Because we said for a negatively charged ion to be formed, electron must be gained. So chloride ion having one negative charge tells us that it gained 1 electron. So when we add the 1 electron to the 17 electron it already had as an atom, it means it contains 18 electrons as an ion. So we can write the electronic configuration of the chloride ion using this. We have 1s2, 2s2, 2p6, 3s2, 3p6, a total of 18. 2, 4, plus 6, 10, plus 2, 12, plus 6, 18. That's for chloride ion. And that tells us that right electronic configuration of ions, we have to take a leaf on or from the atomic number. And then we should be able to understand what happens when an ion is formed. I want to repeat that when an ion is formed, it's either electron is gained or electron is lost. So when electron is gained, a negatively charged ion is formed. And when electron is lost, a positively charged ion is formed. We'll take one problem from writing electronic configuration of a positively charged ion. Say sodium ion with 11 as atomic number. And that tells us that this sodium ion contains 10 electrons. And you may ask why, since we are seeing 11 here. As an atom, sodium contains 11 electrons. But as an ion, it contains 10 electrons, having lost 1 electron. So we can write the electronic configuration of sodium ion representing 10 electrons. We have 1s2, 2s2, 2p6, and that sums up to 10 electrons. 2, 4, 6. This is where we are going to stop for today. Don't forget to turn on the bell for subscription. Don't forget, so that you can get subsequent videos. Please subscribe to this channel and then turn on the bell for the notification bell so that you can get more videos from this. As next time we will continue with writing electronic configuration, because I discovered that a lot of students have problem in writing electronic configuration of elements or ions, or even for transition elements. Thank you. Thank you for watching. Don't forget to subscribe to this channel so that you get subsequent videos. If you have questions, please drop your questions in the comment section.